Hello everyone and welcome to my OSPF Open Shortest Path First video lab demonstration. Uh, it's my first time using the Windows gaming bar, the Xbox whatever. Uh, I forget what it's called, but my snipping tool is not cooperating with me, so trying this out. Hopefully it works. If it does, here's my new video recording app. Hey, so let's get started with our OSPF. In this lab, we will learn how to configure OSPF, of course, opening the shortest path first in our routing configuration. We will establish OSPF neighbor relationships. We will advertise networks in OSPF and verify, of course, that it is working. And we will be doing this mainly through our traceroute command on our PCs. Why these are important? It is a link state routing protocol that dynamically learns and maintains network routes based on cost metrics. Unlike the RIP, OSPF provides faster convergence, scalability, and supports large enterprise networks. So as you can see in our topology, routers, it says 3 routers. I changed it to how many we got here? 6, because I mean, if you have 3, you can get the multiple paths, right? And of course, I forgot to change this. This is now a PDF, so I can't change it. But yeah, so we're using 6. I mean, you can use 5, you can use 4, but you got to use minimum 4, right? Because you need those 2 different directions, the 2 paths. We need a switch connected between each router, and we're going to have PCs connected to each switch. So this may look a little bit complicated at first, but I promise you, once you do it yourself, it's not really complicated. Okay, so let's get to it, shall we? Again, by the number of routers, you can tell this would be in a large enterprise. Is mostly when you're going to see OSPF, unlike EIGRP. Yeah, like companies like Amazon, where you have multiple data centers, you have multiple what am I trying to call it? Regional offices, branch offices, that each need a router or a couple of routers in there. So you got multiple routers. That's mainly where you're gonna see it. Okay, you're not gonna see it in a smaller company with just one office. So I mean, you might go through your whole career never seeing it, never using it. It might be all you use at some point, depending on where you work, right? So let's get to it. As you can see in my topology, we got our 6 routers, our 6 switches, 6 PCs. And I tried to configure this kind of as simple as possible because we're really just trying to focus on the basics here of OSPF. So I got router 1 and I go clockwise to switch 1 with PC 1, to router 2, switch 2, PC 2, router 3, switch 3, PC 3, and so on and so on. I tried to have the IPs of our networks, as easy to remember and similar as possible. Like with R1, we're on our interface, first interface is using 1.1. It's on network 1.0. It goes to switch, or the next router interface, sorry, is .1.2. And then we go to network 2.0, with the interface 2.1, 2.2, and the same and so on. We get to network 3. It starts on router 3 with network, the gateway 3.1, and so on and so on. I mean, you could do it whatever way you want. This just made it easy, at least for me, in my mind, to remember. So I'm not like, oh, what's the IP? What's the IP? What's the network on? What's the network on? It's kind of very straightforward. I also try to make the interfaces the same. 0.0.1 is always connected to 0.1 on a switch. 02 is always connected to 000 going this way. And again, you can see 001 connected to 01 on the switch, and then 000 to 002 on the next. Again, just to make it as simple as possible. I didn't want to have to worry about interfaces. I didn't want to have to really worry about IPs. Again, because there are so many, and for simplicity's sake, for efficiency's sake, this seemed the most, this made the most sense to me when I set it up. So let's get started. So you're gonna have to configure when you decide what network you're on. Like I said, this here is network, 1.0. So figure out what network you got in between each router. Set up the interfaces. So I recommend for this, because there are so many, just doing it in the GUI. I mean, if you want to do it in the command line, go ahead. But I mean, you could just go to interface 001 or 000, put in the IP of the interface 6.2. You can see there. Do the same for 0.1, right, which is 1.1, as you can see there. I'm working on 192.168. I just didn't want to write the whole IP out because it just takes up a lot of space, makes it more messy. Yeah, so let's get to it first. Oh, and don't forget to, set up the IPs and the gateways of your computer. This computer, PC1, is in network 1.0. So again, the gateway would be 1.1. The IP for all the PCs, for me, in mine, they're gonna end in .10. You know how much I love .10. Why? Who knows? But yeah, again, just for simplicity's sake, so when I'm pinging, when I'm trace routing, I don't have to remember, is this dot 132, or like I just boom, .10, simple, you know, keep it simple, stupid. I'm not gonna say I'm stupid, but hey, it's a good saying. It's a good saying to follow, right? Um, and again, you're gonna do it for all your switches, the interfaces, whatever you're connected to, right? The 01, the 02, make sure they're set up, make sure they're on. And my PCs are all connected to the switch on FA0.10. Again, just for simplicity, right? So let's get to it, shall we? We're gonna get into our router. We're gonna get into the command line. You can start on any router, it doesn't matter. We're gonna get ourselves into, oh, we're already in config interface. Okay, so we're gonna start right from the beginning. Let's get into enable mode. We're in enable mode. We're gonna get into config mode, our beloved config mode. And then we're gonna start, so with OSPF, you can, like, I mean, when you set up this OSPF right off the bat, your router will get an ID. It'll just get a random ID before you set it up manually. It's definitely recommended that you set the ID up manually, just for your control sake, right? Configuration sake. So usually, again, and with these, like router.1, so let's see. You can do it in two ways. What am I gonna do first? So let's do this one first. So before we get into OSPF, before we enter that configuration mode, we're gonna create on the router. This is one way to do it. A loopback interface. You're gonna do this by not int. Let's do interface. Come on, come on, come on. Let's do it right. Let's do it right. Right? It's always good to do things right. Interface loopback 0. You're going to give it an IP address, and you're going to give it, so I'm going to give it something simple. For router 1, I'm giving it 1.1.1.1. And this is going to be the router's ID for the OSPF. And then because it is this type of IP, the subnet mask is going to be 255, 255, 255, 255, right? These are all the same. It's going to be all the same. You're gonna create it. For you, I've already created it. For you, it'll say da 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 is now up. Okay, loopback 0 is now up. So you don't have to do no shut because it does it automatically, right? So now that we've done this, I'll show you another way to do this to manually set up the ID. This is probably a little bit quicker, but I mean, really, it's probably the same amount of time. So we're gonna put in router OSPF, and then we're just gonna call it 1. So this is gonna be our OSPF 1. This is our group. Now you have to distinguish what networks are on there. So for OSPF1 on this router, the networks that are connected to this router are network 1, right, and network 6, right, 6.0. And we're also gonna have to well, we don't have to, but we're also going to want to, what's the word I'm looking for here, guys? What's the word I'm looking for here, guys? Help me, help me. To broadcast, well, I'll use that word. To broadcast the ID of the router as well. Okay, so you're going to put network, and you're going to put the one that you created here. And we're going to use a wildcard mask instead of the subnet mask here. So you remember how it was 255.255 times 4? It's going to be 0.0.0.0. And you're going to put in area 0. Okay? And so this will broadcast the ID of the router. You'll see when we look at the neighbors in the routers, it'll show, oh, this is neighbor 1.1.1.1 when we check over here, right? So you're going to hit enter. For me, and I mean, if you do this without, so let's get rid of this because I'll show you the other way to do it in here. So in here, if you didn't do this and create the interface, in here how to create the router ID is you would just put router, don't forget the dash, there's always a dash somewhere, router ID, and then you'll put 1.1.1.1, and oh, would it be this, or would it be what we did up there? I think it would be this up here. It would make sense to be this up here, right? 255.255, and I gotta get that space in there, and I gotta get that 5 in there, and it would be like that. And then once you put that in, oh, and you gotta get rid of that there too. Don't forget to get rid of that. You can't have 2 of these. Okay, and once you put this in here, it'll say, oh, you need to clear up the OSPF configuration. You need to clear it and restart it before this takes effect. And so I'll show you the command to do that later. You do that after you configure all of that. Okay. I prefer this way, creating the loopback. But again, you do whatever you want, right? So once we do that, we're defining the networks again. We got network 1.1.1.1. We got the wild, and you got to put area 0 there, because this is our area 0 in our OSPF, right? So you're going to put it in. You're also going to put in network 192.168. For me, 1.1. I mean 0. Sorry, not the gateway, the network. And you're going to put, for the wildcard again, the wild mask 0.0.0.255, and don't forget the area 0 because you're putting it in area 0, right? So you're gonna hit enter, yeah, and then you're gonna do it one more time for the. Ooh, that's not good. That's not good. We're gonna fix that. Let's just fix that right now before we forget. 0, not 9. There we are. Okay. And we're gonna put in the last one. Right? Remember, we're on network 1, but we're also connected to network 6, right? So you're going to stick that in there. And there you have it. You have your OSPF set up on router 1. So you would do that on every single router. Router 2, you know, your router ID. I mean, you can name it whatever you want, right? You want to name it Captain America, go ahead. But again, for here, simplicity's sake, we're just naming this. The ID was 2.2.2.2, right? 3.3.3.3, 4.4.4.4, so on. Remember, you got to connect it to the routers, I mean the networks. So router 2 is connected to network 1 as well as network 2. Router 3 is connected to network 2 as well as network 3. Excuse me. So once you have all of that configured, we'll do it on router 6. Let's see. So we're gonna get in here. We're gonna start from the very beginning. We're gonna go enable. We're gonna go. So again, we're gonna check. When we're checking most of our configurations, we're checking in enable mode, right? So we're gonna do. Let's do show IP OSPF. Okay, so now this is gonna show our configuration, the OSPF configuration for this specific router. So you can see the router ID 6666, right? Again, because it's router 6, why not? Again, you can name it whatever you want, right? You like Spider-Man? You like Iron Man instead of Captain America or instead of Batman? I don't know who likes Iron Man instead of Batman, man, but hey, I'm not gonna judge. Okay, so what else? These are more advanced stats that you could see when you create different areas, which we will do in a more advanced video. Again, this is more for the basics, right? So we'll worry about that later, all the areas. What else? Again, this is more for the areas. It's showing you how many routers it's connected to. 1, 2, and 3. There are 3 routers in this area that it's made up, right? So you can see things like this. What else can we see? What else can we see? Let's check out our neighbors here. Show IP OSPF neighbors. I think it's neighbors and not neighbor, but hey, maybe it's neighbor. Okay, it's neighbor. Sorry, guys. So now it's showing us our neighbors, right? Remember how we made this 1.1.1.1? There it is, right there. You can see the address of the interface that it's connecting to. You can see the dead time. Not a lot of dead time there, right? And you can see its state. The neighbor's state. Okay. What else can we check here? We can show IP route. Right, and now this is just going to tell you what route it takes when it sends out, when we send out data, where we'll go to the router, right? The router ID via this here. So if we're sending data this way, boom, it's going to go to router 1111 through interface 62, right? And then you'll see this, and it'll go to 2222 via this. So we'll get here. We'll get to this router via this interface over here, and it's going this way, right? And if we're going a different way, you'll see, like in this scenario, if we're going to go to router 3333 over here, it has decided, for some reason, I'm not really sure why, it's just decided this because it's the same direction, right? Same amount of routers. It's choosing to go this way instead of this way, and you can see this by it saying, oh, if it's going to 333, it's going to go via interface 5.1 down here on router 5, right? So it's going this way instead of that way. So those are the main things that you can see here. Now how we're really going to tell that it's working is by using traceroute on our PCs. So instead of, if we trace route this PC to this PC, it's not going, oh, let's go all the way around here. It's just going right there, right? That's the whole point of this thing. So let's get in here. Again, we've set up our gateway. We've set up our IP and the network that it's on, PC6. We're gonna get to our desktop. Let's make sure we can ping. Right? We gotta make sure everything's connected. So we're gonna ping PC1 over here. And again, sometimes on packet tracer it may go like, oh hey, we're gonna take a whole lot of time. Oh, we might have to troubleshoot. Oh, no we don't. Okay. That is the most stressful 5 seconds in IT, waiting for the ping on packet tracer. You're like, oh, do I look like a fool? No, I don't. I did everything right. Okay. So yeah, just give it a little time and eventually it'll ping. It'll get it. So the ping works. They're connected. Okay, so let's trace route. And we're going to trace route the same IP. We're going to go there, 1.10. And here you go. It's going to say where it went, right? And how fast it got there. 1 millisecond. That's pretty fast, man. So we went from our network over here, and we went this way, right? It checked 161, and it was like, this router was like, no, this is not the fastest way. Sorry, bro. So I went, okay, then this must be the fastest way. 6.2, right? And it went, yeah, this is the fastest way. And we got there. So you saw it in action right there. It checked the path. It checked the path. This one said, nope. This is going to take really long. And it's not scenic. This is not a beautiful route. It looks exactly the same, as just longer. Why would you take this? We wouldn't. And so we said, okay, we'll take this one. Let's make sure it works on oh well, let's look, let's go to PC3. Let's see what way it takes. So we're just gonna put in our trace route. We're gonna switch the network and we're gonna trace route. And so through here, let's get it back to normal size for myself. It took 6.1 to 5.1 to 4.1, and it already knew this was the right way. It already had the neighbor's information. It didn't even check this way this time, right? Because we checked last time which way. And when we checked that last time, we did that first trace route. It went, okay, here's all the neighbor information on you. Here's all the neighbor information on you. So now when we trace route the second time, it doesn't need all that. It doesn't need to check both. It knows this is the right way to go. This is the way I'm going, right? And where do we go? We go here. Why did it decide this? Again, I don't know, because it's the same way. So let's do a different one. Let's get where are we gonna go? Let's go here to here. This will really test it out. Okay, because this path again is shorter than this path here. Let's do it. So we're going to 4. We're going to 4. Okay, so to get to 4, it chose the right path again. Doom, doom, doom. Instead of going the long way. So we know it works. And again, it didn't need to check because it checked the first time. Right? What paths you got? What paths you got? And so the next time we did it, it didn't need to go, oh hey, what paths you got? What paths you got, neighbor? We already knew. I'm going this way. Right? It didn't have to look at 6.2. It already knew 6.1 had it. Boom, boom, boom. Gaming bar worked. Xbox worked. I'm normally a PlayStation guy. But today, at least for right now, at least before I go and play some, what am I gonna play? What am I gonna play? Maybe I'll go back to some Cyberpunk. I don't know, man. I've been building the Netrunner thing. I've been playing as that, Corpo, seeing how that story goes. Maybe I'll go do that. Maybe I'll play Madden. I mean, who knows? Who knows? So, you have set up your OSPF, man. You've configured each router with an ID or a loopback. Yeah, through your loopback address or through the router ID process. They look like that. You've done it to all routers. Every router needs an ID. You've set up the interfaces. You've configured the OSPF with the networks. You've configured them to area 0. We're only doing an area 0 right now. No stub areas. No area 1, no area 2, just area 0. You've checked neighbor relationships. You've checked routing tables. You've checked the show IP OSPF to check your own router's ID, right? So you've checked the stats, you've checked the configuration. It's all worked. You've pinged connectivity, it's worked. And you've checked trace route to make sure it is indeed taking the shortest path, which it is. My daughter is knocking on the door for some reason as I'm taking this, so I must say goodbye. Holy OSPF Batman. If you're under the age of probably 30, you have no idea what this is. I mean, even if you're 30, even if you're my age, you might not know what this is. Retro Batman, Adam West. Holy smokes, Batman. Holy OSPF to you. You've done a great job. You have successfully configured OSPF, ensuring the dynamic and efficient routing in your network. Thanks to you, your network data won't ever have to take the long way again. Data, whatever you want to call it, that's up to you. Yeah, power to you, more power to you. I hope you enjoyed the lab. I know I have, especially now that it is recorded fully. Thank you for watching. Take it easy, and we'll see you next time.